All right, let's get into a thought experiment that's, well, a little bit ridiculous, but also really revealing. We're going to take a simple idea and use it to unravel pretty much everything we know about how our planet works. So, yeah, buckle up. Things are about to get weird and a little wobbly. And there it is, the big one. I know we talk a lot about rising sea levels, but just put that aside for a second. Imagine, what if every single drop of salt water, from the surface all the way down to the Mariana Trench, just instantly became jelly? What happens next?
Okay, so like any good thought experiment, we've got to have some ground rules. Our jelly ocean is not a liquid. Think of it as one single, massive, planet-sized solid. It can jiggle, sure, but it can't flow. And this distinction, this is absolutely critical, because as you're about to see, the simple fact that our oceans are liquid is what makes life on Earth even possible.
So, picture it. The switch is flipped. The oceans are now gelatin. What happens in those first few seconds? Well, the consequences are immediate, and they are absolute. We're talking about a complete and total planetary shutdown.
Just think about it for a second. The constant sound of our planet. It's the sound of moving water, right? The crash of waves on countless coastlines, the gentle lapping in a quiet harbor, the deep, massive groan of ocean currents. All of it just gone. In an instant, this profound, almost eerie silence would fall over more than 70% of the Earth's surface.
And this really shows the total paralysis. I mean, every single wave would be frozen in place, creating this bizarre, static landscape of glassy peaks. The moon's gravity is still pulling, of course, but without liquid, it can't create tides. And those massive ocean currents, the planet's circulatory system, they just grind to a permanent halt. Yeah, and a really, really bad day for surfers, to say the least.
Now consider this number, 6,000. That's roughly how many huge container ships are out on the open ocean on any given day. They're carrying everything from our cars to our coffee. They're the absolute lifeblood of our global economy. And they all have a very big problem. Because now, they're all just museum pieces. They're stuck fast in a planetary jello mold. Every single one of them, plus every submarine, every fishing boat, every cruise ship, permanently immobilized. Global trade doesn't just slow down, it literally ceases to exist in a single moment.
The problem, though, it builds really fast from a physical one to a full-blown climatic catastrophe. The immediate gridlock is shocking, for sure, but what unfolds in the first few days? That's what truly begins to dismantle life as we know it. The planet's entire operating system just starts to fail.
Right, so here's the thing. Rain starts with evaporation from the ocean, but our jelly ocean has a solid, rubbery surface. It's like putting a lid on a giant pot of water. No steam can escape. So it's a simple, brutal chain reaction. No evaporation means no new water vapor. No new water vapor means no new clouds, and no clouds means no rain. The planet's water cycle breaks at the very first step. This comparison really gets to the heart of it all. Our liquid ocean is this dynamic engine. It churns, it evaporates, it uses currents to move heat from the equator to the poles, kind of like a massive global radiator. The jelly ocean, though, it's just a static insulator. It would absorb the sun's heat, but it would have no way to distribute it. Coastal regions would bake during the day and then freeze at night, and without the temperature differences of dry wind, our weather patterns would just collapse into chaos.
Okay, so our planet is now silent, it's static, and it's rainless. But what about the long-term biological impact? The famous line from Jurassic Park is, "Life finds a way." But could it find a way in a world like this?
This right here, it's one of the most vital and honestly kind of invisible jobs the ocean does for us. It absorbs a massive amount of carbon dioxide from the atmosphere. Without that liquid process, the CO2 we produce would just have nowhere to go. It would build up and up and up in the atmosphere, trapping heat and triggering a runaway global warming far beyond anything we could even imagine. The pressure cooker would definitely be on.
And then there's the very air we breathe. We always thank the rainforest for our oxygen, and we absolutely should. But look at this. They're only half the story. A full 50% of the Earth's oxygen comes from these tiny marine organisms, phytoplankton. Trapped in an opaque solid jelly, they would die almost instantly, and with them goes half of our planet's ability to make oxygen.
So the dominoes just fall really, really quickly after that. Whales, fish, crabs, pretty much anything that can't burrow out is gone.
Mangroves and tidal pools, which need that ebb and flow of water, they just dry up, die. The land, starved of rain, becomes a desert. And the entire global food chain, which is built on a foundation of life in the sea, completely unravels.
So, after all that doom and gloom, you might be asking, why even think about this, right? What's the point of such an absurd scenario? Well, it's because by imagining how the world breaks, we can get a much, much better understanding of how it actually works. This gelatinous globe has something really important to teach us about our real liquid one.
And the simple truth is this. The ocean is not just a big body of water. It isn't some passive feature on our planet. It is an active, living, interconnected system that is fundamentally responsible for making Earth habitable. We totally take its liquid, dynamic nature for granted, but as we've just seen, it's the key to, well, everything.
So here it is, the ocean's real job description. It's our thermostat, moving heat around to keep the climate stable. It's our carbon sink, cleaning the atmosphere. It's the engine of commerce, connecting our world. It's a primary oxygen generator, literally creating the air we breathe. And above all else, it's the cradle of life, the place where it all started and the system that sustains it all today.
And that really brings us to the final, crucial point. No, our oceans are not turning to jelly, but they are changing. They're getting warmer, they're becoming more acidic, their currents are shifting. This whole strange thought experiment, it's really just a powerful reminder of what the ocean does for us and what's truly at stake. So the real question isn't what would happen in some fantasy world, but how we are going to respond in ours.